how we can use the ceramic capacitors to find or to detect the short circuits in the motherboard. I'm going also to teach you the purpose of the ceramic capacitors in the motherboard and much more. So basically we gonna see in this video two parts, a theory part and a practical part, where I'm going to teach you how to test ceramic capacitors, any kind of ceramic capacitors, using the multimeter step by step. So let's get started. But please, before diving into details, make sure you subscribe and click the notification bell to stay updated for future videos. Multi-layer ceramic capacitor. A multi-layer ceramic capacitor, MLCC, is a fixed value capacitor. This type of capacitor is generally magnetic interference between electronic components. The ceramic capacitor is no polarized capacitor. Okay, so here we have a cross section of a ceramic capacitor. As you can see, it is composed of many layers. As you can see here, the insulation material between layers. Okay, so here, as you can see, we have the ceramic capacitor terminals. Okay, this is terminals. Okay, exactly like this. And of course here, this is the metal electrode, okay, and here this is the dielectric or insulation materials. So now I'm going to show you how to calculate the ceramic capacitor code. So using the same working principle as the resistor. So the first and the second digits are fixed numbers, okay. The third digit is the multiplier. Okay, so the third digit is the multiplier. But for the ceramic capacitor, the fourth digit or letter is the tolerance. So if you find J means 5%, okay, K 10%, M 20%. See an example. For example, let's say we have a ceramic capacitor with 104K. So this code means 10 and 4 zeros, as you can see. So plus or minus 0.1 microfarads. So 0.1 microfarad, as you can see, is the tolerance, because here we have the K, so K 10%. Okay, so 10% of this number. We have here three numbers, so always, as you can see, the first digit, the second digit, and this is the multiplier. But if we have four digit, as you can see here, so the first digit, the second digit, we have the multiplier, the digit number 3, and the fourth digit is the tolerance. Okay, the tolerance, this digit have to be J or K or M. Okay, here we have some examples. So we have 1, 0 and 4 means, as you can see here, 100 picofarad. Okay, here we have 473 J, so means, as you can see here, 47,000 picofarad. Okay, and J, the tolerance is 5%. Always the ceramic capacitors are measured with picofarad, but for the electrolytic capacitors and tantalum capacitor, the unit is microfarad. So now let's see the symbols of capacitors. So basically there is two types of symbols. Symbols for polarized capacitors and non-polarized capacitors. So as you can see here, all the symbols are the same. So here, this is a symbol for a polarized capacitor, for an electrolytic capacitor. Here we have plus and minus. Okay, always the top terminal is the plus. Here we have plus and minus. So this is plus and this is minus. This is the positive terminal and this is the negative terminal. Okay, always the top terminal is the positive terminal. Here, as you can see, we have plus and minus. And here, this is the positive terminal and this is the ground terminal. Basically, these two symbols, are a U key symbols, and those are a US symbols, okay? So, but for the polarized capacitor, we used usually this two kind of symbols, this and this, okay? For non-polarized capacitors, we have these three symbols, but we used usually these symbols, as you can see. So this is also a UK symbol, and here this is a US symbols. So, but we use this usually. So as you can see, this three symbols doesn't have the plus and minus sign, okay, because those are no polarized capacitor. So now let's see how to test capacitor. Of course, before diving into testing capacitors, I want just to add that the capacitors, as you can see, for the polarized capacitors, you should respect the polarity. I mean, you should always put the red probe of the multimeter in the positive terminal, and the negative probe or the black probe here in the negative terminal, okay? But for non-polarized capacitor, you can use the probes as you want. You can put the black hair and the red hair, or the red hair and the black hair. So as you can see over here, this is basically the ceramic capacitors that we gonna test using the multimeter. So I want just to see that you can find many types of ceramic capacitors in laptop motherboards and computer motherboards. For example, you can find this kind of ceramic capacitors, big ceramic capacitors. Also here we have other ceramic capacitors, as you can see over here. So to test the ceramic capacitors, we gonna use, as you can see here, the continuity option. We gonna use this option. So let's begin and test, for example, this big capacitors over here. So we can just put one probe here, okay, and the other probe in the other terminals. Do you see? We get a reading here in the multimeter. We should not get a reading like this, a 0 in the multimeter. If we get a reading like this, means the capacitor is shorted. Okay, so let's check the second one over here. Okay, we have here the same reading. So these capacitors are good. So I want to add here that, for example, this capacitor is not like this one in terms of size. So if you have, for example, a failed capacitor like this one, you should replace it with another ceramic capacitor with the same size and same color, because above ceramic capacitors we don't have here values like, for example, tantalum capacitors or electrolytic capacitors. That's why if you find a failed ceramic capacitor, you should replace it with another one with the same color and same size. This, for example, and this are same, okay? But as you can see here, this one, for example, and this one are not the same. This is a brown color, and this color, as you can see, is not like this one. Those also over here are not the same as this one. So, for example, if this one is failed, do not replace it by this one or this one. You should replace it by another one. For example, these two are the same. These two here are same. This one, no. Okay, so this is how you can replace ceramic capacitors. Here also, as you can see, if for example this one is failed, we can replace it with another one with the same size and same color. But for example, do not replace this one by this one. Okay, so over here we have many ceramic capacitors. Basically here, this is the back of the IC head. Okay, so for this kind of ceramic capacitor, so if we test it, as you can see, let's check it. For example here, do you see we get in the multimeter about 17, a low reading, as you can see. Let's check another one, for example. As you can see, this is not a short circuit. So for chipsets, always we will get a low reading. Okay, so because these capacitors are under the ICH. That's why we get this reading. I can even prove to you. So I'm going to prove to you in this motherboard. So we have here the processor, okay? So under the processor directly we have ceramic capacitors, many ceramic capacitors. So let's check, for example, these ceramic capacitors, okay? So this is the ceramic capacitors under the CPU socket, okay? So let's check any ceramic capacitor. Let's check this one, for example. Do you see we get in the multimeter a very low resistance? Let's check this one also. As you can see, this is a short. No, this is not a ceramic capacitors. So this is the two ceramic capacitor that we have test. So let's test it again. So one probe here and the other probe here. Do you see in the multimeter? We get 700. Let's check this one also. 700. Okay. If we put back the processor, so if we put back the processor, as you can see, no, the processor is installed. So let's check again, just to make sure. Just to make sure. So one probe here, the other probe here, as you can see in the multimeter. We get a short. This is not a short. So please, guys, remember, always for chipsets, okay? Always for chipsets like the CPU, the graphic card or North Bridge, and the ICH, always the ceramic capacitors, as you can see, that you're gonna find in the back of the chipsets. You will usually, not usually, but always you will find a very low resistance. This low resistance is not a short circuit. So please remember, because many technicians find like this short and try to figure out where is the short circuit exactly. But no short circuit, it's not the short circuit, it's normal. But for the ceramic capacitors that are not belong to CPU circuit or other chipset circuits, you will find a normal reading, as you can see here, for example. Do you see? Normal reading. Okay, any ceramic capacitor here, if I find, for example, here a low reading, means we have a short circuit. But here, guys, I want to add an exception. Here, basically, this is a shorted motherboard. The short is in the CPU circuit, okay? The short is in the CPU circuit. So, the CPU now is installed. If I check this ceramic capacitors, as you can see, do you see? We have 0 in the multimeter. Do you see? This is a short. Okay, let's check this one also. Do you see? We have 0 in the multimeter. Means this is a short. Okay, so let's remove the CPU. If we check even this big capacitor, the 10 term capacitors, we can find also a short circuit. Let's check it. Do you see? We have 0 in the multimeter. Means here we have a short circuit. Even if I remove the CPU, so basically this is the CPU. If I remove it, so let's remove the CPU. As you can see, the CPU is removed. So as you can see, the CPU is removed. Okay. So let's check the ceramic capacitors. As you can see, do you see? We get 0 in the multimeter. Okay. This one also. So if you check this one, as you can see, 0 in the multimeter. Means we have a short circuit, a clear short circuit in the CPU circuit that I'm going to teach you how to find it and how to troubleshoot it step by step. So please remember, let's summarize what we have seen before. So ceramic capacitor, okay? Okay, So the symbol for the ceramic capacitor is this one. Okay, it's not polarized capacitor. This is basically the ceramic capacitor. But for electrolytic, okay, capacitor, its symbol is, as you can see, this. We have here plus. Okay, or you can find also this symbol. This also means minus. Okay, so capacitor, okay, is good. But in the CPU, as you can see, circuit, you can find the value is greater or equal 003, okay, and 30 ohm. Okay, so if you find 003 or 004 or even sometimes 002, it's okay, it's not a short circuit. If it's the CPU, if you can remove it and check, it will be better. But if the chipset is integrated, anyway, a low value doesn't mean a short circuit unless you find 3 zeros. If you find 3 zeros, means automatically you have a short circuit. Then we have seen that if you find, for example, a ceramic capacitor, a bad ceramic capacitor, this is, for example, you find this bad ceramic capacitor, you should replace it with another ceramic capacitor with the same size, okay, and same color. Okay, same size and same color, because above the ceramic capacitors you cannot find the value unless you have the schematic. If you have the schematic, then you can find the value of ceramic capacitor. This is an example, as you can see over here. This is a ceramic capacitor. We have the schematic. Here we have 4.7 microfarad, 25 volt. Okay, as you can see. And for this one, we have 10 microfarad, 25 volt. So if you have the schematic, as you can see, you can find the value of any component you want. So, and as I told you before in the previous videos, so this is basically an IC. So next to each IC, you will find many ceramic capacitors, as you can see over here. Okay, many ceramic capacitors. So the ceramic capacitors are always connected to the ground in one side and connected to the IC in the other side. That's why if you find, for example, that these 3 ceramic capacitors are shorted, means the IC is shorted. So this is the second method that we use to check the serviceability of IC. So to understand clearly, I can even draw here an IC. This is, for example, an IC. Okay, so this IC basically, we have here, for example, VCC in this point. For example, let's assume we have 19 volt VCC. We have, for example, 2 enable signals, enable 1 and enable 2. Okay, and over here we will get, for example, an output. As you can see here, this is basically output here. Okay, we will get, for example, 3.3 volt. Okay, so then you will find, as you can see here, some ceramic capacitors, okay, that are connected to the ground. So all ceramic capacitors near integrated circuits are connected to the ground in one side and to the IC in the other side, and of course the IC also is connected to the ground in the other side. So if, for example, let's assume we have C1, C2 and C3. Okay, so if this one, for example, is shorted and this one is shorted and this one is shorted, means what? Means here we have ground and also here connected to the ground. Means the IC, the shorted here is the IC, not the ceramic capacitors. So based on my experience, when I find many ceramic capacitors are shorted, means the IC is connected to the ground, because here this ceramic capacitor is connected to the ground. In this side, find this one shorted, but the shorted one is the IC, not ceramic capacitor. So basically this is the second method that I use to check whether the IC is bad or not. But the first method is by checking the heat of the IC. Use your finger. If you find that the heat is not normal, a very hot, means the IC is bad. And the third method is by checking the inputs and the outputs. So, for example, basically we should get here 3.3 volt as an output. But if we didn't get 3.3 volt, doesn't mean that the IC is bad. We should first check inputs. We should check VCC 19 volt. Is it present or not? We should check these two enablers. Basically, for example, here we have 3 volt and this one 3.3 volt. We should check these two enablers. If we find that all inputs are present, 19 volt are present, enable signal, enable 1 present, enable 2 present, and other input signals, for example, like V reference, for example, and for example, shutdown, the shutdown signal, for example, are present. If all inputs are present and the 3 volt still missing, means the IC is the